Hi everyone. In this lesson, we're going to review some important foundational concepts in geometry. Let's get started right away. Lines. First up, what is a line? In everyday life, we might think of a line as just a straight mark, but in geometry, a line extends forever in both directions. That's why we draw it with arrows on both ends. Let's place 2 points on this line, say A and B. We can name the line as line AB, line BA, or even line AC if we add another point C on it. All those names are correct, as long as they're points on the same line. Rays. Next, let's talk about a ray. A ray starts at one point and continues forever in one direction. It has a starting point and one arrow. For example, if we have points A, B, and C on a ray that starts at A and passes through B, we call it ray AB. We can also call it ray AC. We can't call it ray BA or ray BC because the first letter must always be the endpoint, the starting point of the ray. Line segments. A line segment is different from both a line and a ray because it has 2 endpoints. If we draw a segment between points A and B, we name it segment AB or segment BA. No arrows, just a straight connection between 2 points. Angles. Now let's go over some basic angle types. An acute angle measures less than 90 degrees. If you notice, angle ABC is formed by the union of 2 rays, ray BA and ray BC. The point B is where the 2 rays meet, and it's called the vertex of the angle. The vertex is always written in the middle when naming an angle. So we can say angle ABC or angle CBA, both are correct. Right angle. A right angle measures exactly 90 degrees. Obtuse angle. An obtuse angle measures more than 90 degrees but less than 180 degrees. Straight angle. A straight angle measures exactly 180 degrees, forming a straight line. Midpoints. A midpoint is the point exactly halfway between 2 endpoints on a segment. So if B is the midpoint of segment AC, then segment AB is congruent, equal in length to segment BC. We can show that with tick marks and write it like this. Segment bisectors. A segment bisector is a line, ray, or segment that passes through the midpoint of another segment, cutting it into 2 equal parts. For instance, if ray RB passes through the midpoint B of segment AC, then ray RB is a segment bisector. Ray RB bisects the segment into 2 congruent parts. We can see that segment AB is congruent to segment BC. Angle bisectors. An angle bisector splits an angle into two equal angles. If ray BD divides angle ABC equally, and angle ABC measures 60 degrees, then both angle ABD and angle DBC measure 30 degrees. Always remember, the vertex goes in the middle when naming an angle. Parallel lines. Parallel lines never cross. They stay the same distance apart forever. For example, line A and line B are parallel if they have the same slope. If the slope of line A is half, then the slope of line B must also be half. Parallel lines are represented by this symbol. Perpendicular lines. Perpendicular lines are two lines that meet or cross each other to form a right angle. That's a 90-degree angle. Here's the trick with slopes. If two lines are perpendicular, their slopes are opposite reciprocals. That means you flip the fraction and change the sign. Example, line A has a slope of 2/5 and is perpendicular to line B. Then the slope of line B must be the opposite reciprocal, which is -5/2. Perpendicular lines are represented by this symbol. Next concept we are going to cover is complementary angles. Imagine a triangle, triangle ABC. Let's say the measurement of angle A is 35 degrees and the measurement of angle C is 55 degrees. Since 35 plus 55 equals 90, angles A and C are complementary. So the measurement of angle A plus the measurement of angle C equals 90 degrees. Following that, we have supplementary angles. Based on the last topic, you can probably guess what this is about. Supplementary angles are angles that add up to 180 degrees. Remember, a straight angle measures 180 degrees, so we need to consider a straight line. So let's put some points. Let's say this is point A, B, C, and D. Suppose the measurement of angle ABD is 120 degrees. What is the measurement of angle DBC? Since 180 minus 120 equals 60, angle DBC measures 60 degrees. Because angle ABD plus angle DBC equals 180 degrees, these two angles are supplementary. Next, let's discuss the transitive property. What is the transitive property? If two angles are congruent to the same angle, then they are congruent to each other. For example, if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 2, then angle 1 is congruent to angle 3. It may seem obvious, but this is very useful when working with two-column proofs. Another way to say this with variables: if A equals B and C equals B, then A equals C. That is the transitive property. Next, you need to be familiar with vertical angles, especially if you're working on two-column proofs or similar geometry problems. So what are vertical angles? We create vertical angles when two lines intersect each other. Let's label the angles formed as angle 1, angle 2, angle 3, and angle 4. Now, opposite angles are always congruent. That means angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. These pairs of opposite angles are what we call vertical angles. Let's do an example. Let's say this angle is 65 degrees. What are the other three angles? This angle across from it also has to be 65 degrees because they are vertical angles. Now let's focus on the two angles next to them. Let's call one of them angle X. Angle X and 65 degrees form a linear pair. That means they are on a straight line, so they must add up to 180 degrees. To find angle X, subtract 65 from 180. 180 minus 65 equals 115 degrees. The angle opposite to the 115-degree angle is also a vertical angle. Therefore, it must also measure 115 degrees because it is its vertical angle. And that's how you can use vertical angles to find missing angle measures in geometry. Let's move on to medians. A median is a line segment drawn from a vertex of a triangle to the midpoint of the opposite side. For instance, in triangle ABC, if you draw segment BD, where point D is the midpoint of side AC, then BD is a median. Since D is the midpoint, segment AD is congruent to segment DC. The median splits the side into two equal parts. Next is the altitude of a triangle. An altitude is a line segment drawn from a vertex perpendicular to the opposite side. Using triangle ABC again, if BD is an altitude, point D is on side AC, but it is not necessarily the midpoint. The altitude forms right angles where it meets side AC. Angle ADB and angle CDB each measure 90 degrees. Since BD is perpendicular to AC, they intersect at right angles. Now let's cover perpendicular bisectors. The term perpendicular bisector combines two ideas. First, it is perpendicular to a segment, meaning it forms right angles. Second, it bisects the segment, meaning it divides it into two equal parts. Suppose we have segment AB, and line L is perpendicular to AB at point M, which is the midpoint of segment AB. Therefore, segment AM is congruent to segment MB. Let's add some more points to our diagram. We'll call this point P and that one Q. We can say angle AMP and angle BMP both measure 90 degrees. Let's focus on point P. Notice that segment AM and segment BM are congruent. These two triangles also share a common side, segment PM. Because AM is congruent to BM, and PM is the same in both triangles, we can say that triangle APM is congruent to triangle BPM. That means segment AP is congruent to segment BP. This shows an important property of perpendicular bisectors. Any point on the perpendicular bisector is equal in distance from both endpoints of the segment, from point A and point B. Segment AQ is congruent to segment BQ. These are key facts to remember when working with perpendicular bisectors. A common type of problem you'll see in geometry is proving that two triangles are congruent. Let's say we are working with two triangles, triangle ABC and triangle DEF. There are four main postulates you need to know when working with triangle congruence. We'll focus on just one of them for now. Suppose side AB is congruent to side DE. Side BC is congruent to side EF. And side AC is congruent to side DF. If all three corresponding sides are congruent, then triangle ABC is congruent to triangle DEF. This is called the SSS postulate, which stands for side, side, side. Now, when writing the triangle congruent statement, you need to list the letters in the correct order so that corresponding angles match. For example, angle A corresponds to angle D because they are opposite the sides AC and DF, which are congruent. Angle B corresponds to angle E, and angle C corresponds to angle F. Make sure the order of the letters in both triangles lines up with their matching parts. Let's look at another example, this time using different letters. We'll call this triangle XYZ and the other triangle RST. Suppose segment XY is congruent to segment RS. Segment XZ is congruent to segment RT. And angle X is congruent to angle R. Now, what postulate can we use to prove that these two triangles are congruent? We have a side, an angle, and another side. This fits the SAS postulate, or side angle side. So, we can say triangle XYZ is congruent to triangle RST. That's the second postulate to remember. Once two triangles are proven congruent, we can make more statements. For example, angle Y is congruent to angle S. Why? Because of CPCTC, which stands for corresponding parts of congruent triangles, are congruent. Now let's try another example. Call this triangle MNO and the second triangle GHI. Suppose angle N is congruent to angle H. Segment MN is congruent to segment GH, and angle M is congruent to angle G. We have an angle, a side, and another angle. So we use the ASA postulate, which means angle side angle. Therefore, triangle MNO is congruent to triangle GHI. Once again, we can make more statements. For example, segment MO is congruent to segment GI based on CPCTC. Now let's go over one more postulate. We'll use triangle ABC and triangle RST. Suppose angle A is congruent to angle R. Angle C is congruent to angle T, and segment BC is congruent to segment ST. This gives us an angle, another angle, and a side. So we use the AAS postulate, angle, angle, side. That means triangle ABC is congruent to triangle RST. So far, we've covered four main postulates: SSS, side, 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 SAS, side, angle, side, ASA, angle, side, angle, AAS, angle, angle, side. There is one more postulate called the hypotenuse leg postulate, which is used only for right triangles. That postulate will be explained in another video. Now let's try a composite triangle problem. Suppose triangle ADC has two equal parts. Segment AD is congruent to segment DC. Segment AB is congruent to segment BC. We want to prove that triangle ABD is congruent to triangle CBD. What do we know? We have two pairs of congruent sides. Also, both triangles share side BD. This is called the reflexive property, since any segment is always congruent to itself. So we now have three pairs of congruent sides. That means triangle ABD is congruent to triangle CBD by the SSS postulate. Then we can say angle A is congruent to angle C using CPCTC. That is a quick review of important geometry topics. Want to learn more? Comment below if you'd like more tutorials on geometry. Don't forget to subscribe and click the notification bell to get updates on new videos. Thanks for watching.